Okay, before we start our next lesson, please get out, please get out lesson 4 homework practice on slope intercept form. I just want to make sure that you've done this correctly. Let's take a look at number 10. We have to graph y equals 15x plus 15. Well, the 15, that's the coefficient of x, is our slope, and the 15 is our y-intercept. So over here, you're going to go to the y-intercept of 15, and then you're going to rise 15. So if I'm at 15 now, going up another 15 takes me to 30, and I run 1. Rising 15 takes me to about 45, rise 1, or run 1. So your graph should look something like this. When it says find the total cost for 4 nights, you can go over to your graph for 4 and go up. But just to be sure, you want to say 15, you rise, you go to 30, then you go to 45, then you go to 60, then you'd go up here to 75. So actually my line should have been just a little bit higher. It's going to cost $75 for 4 nights. And this is the most important thing. A lot of my Algebra 1 students struggle with this. If you look at the graph over here, it's really important to label your x and your y-axis. So your x-axis is nights, your y-axis is cost. And so when you have to interpret the slope, a slope of 15, remember, is that you're rising 15, you're running 1. Well, if you look at your axis, rising 15 means you're going up $15, and you're running 1, that's in the x direction, which is nights. So what they want for interpreting the slope is that it costs $15 per night to camp. And to interpret the y-intercept means that at 0 nights you have to pay $15. So that means that there's an initial fee of $15 just to reserve the site, not even counting any of your nightly charges. Okay? Alright, number 11, x plus y equals 90. So if we solve this for y equals 90 minus x. So in this case, our y-intercept is going to be 90. So we go all the way up here on the y-axis to 90, and we're going downward by a slope of 1. So that means if we go down 20, that means it goes down here and over 20. 20 over 20 is 1. So down 20 over 20, down 20 over 20. And you notice that we hit down here at 0, 90. A slope of -1 verifies or looks like the graph. We're slanting downward. Okay, on the back, just double check here real quickly if this is the origin and this is the x-axis, this is the y-axis. This graph is going to hit at 5, and then we're going down 2 over 1, down 2 over 1. So your line should have looked something like this. This one you hit at 1. Ooh, don't like that because we don't really have enough room. So I'm going to go up here and I'm going to make our x and y axis here. I'm going to move our origin way up so we have more room. So now a y-intercept of 1, we're going down 3 over 1. Down 3 over 1. So it should look like this. Okay. This graph, if this is, I'm going to move our origin up again here. Y-intercept of 1. A slope of -1 means we go down 1 over 1. Down 1 over 1. Okay. This one is a y-intercept of +3. So way up here and slanting down at a rate of 1. This graph has a y-intercept of -3, and we're slanting upward at a rate of 1. So that's going to look like this. This graph, if I move my x-axis up here, my y-axis, this graph has a y-intercept of -5. So way down here, 5 down, but a slope of 1. So we're rising 1, running 1. Okay. This graph has a slope of -6. So we're way down here, 1, 2, 3, 4, 5, 6. And we're sloping upward at a rate of 3. So rise 3, run 1. Okay, and this one's a little bit tricky. This is the last one I'll do. We have a y-intercept of -1. So we go down on the y-axis to -1. But this time we have a slope of 5/2. That means we rise 5, we run 2. So rise 5, 1, 2, 3, 4, 5, run 2. It's going to look like this. It's a fairly steep line. Okay. All right, please set this aside. And now we're going to quickly look at another method for graphing a line. We just learned slope-intercept form. So just to review, slope-intercept form is when the equation looks like this. But sometimes the equation won't look like that. Sometimes the equation is what we call in standard form. So standard form of a linear equation is when the equation looks like ax plus by equals c, where a, b, and c are just numbers. So a and b are coefficients of x and y, and c is just a constant. So here's an example of standard form. ax plus by equals c. So this equation, the a value would be equal to 3. In this case, the b value would be equal to -5, and the c value is equal to 15. So when an equation is in standard form, there's an easier way to graph it than solving for y and using y equals mx plus b. And it's to graph by using the intercepts. And what we mean by the intercepts is if the line slanted like this, the intercepts are where the graph crosses the x-intercept and where it crosses the y-intercept. Okay, and we do this by doing a really simple technique. If you think about any point that lies on the x-axis, 1, 0, 2, 0, 3, 0, notice that every point on the x-axis has a y value of 0. So what we do is we're going to create an ordered pair, but we're going to let y be 0. And when we do that, when we let y be 0, if you put 0 in for y, isn't -5 times 0 just going to disappear? It's going to become 0. So this is called the cover-up method. When y is 0, we cover this up and we figure out what makes this equation true. 3x equals 15. Well, isn't x equal to 5? 3 times 5 equals 15. So what we just did is we just found the x-intercept. Put a dot there. Now we're going to do the same thing but to find the y-intercept, and the y-intercept is when x is 0. So when x is 0, 3 times 0 is 0. We cover this up, but don't cover up this subtraction sign that applies to the b value here. So now -5 times what is positive 15? -3. So we put a dot at -3, 0, -3, and we just graphed our intercepts. We've got 2 lines, or 2 points on our line, so that's enough information to graph our line. And we were able to successfully graph the line without solving for y and doing the slope-intercept. We got the same result. Okay, let's jump to this one. Let's use the cover-up method. So we're going to let y be 0, and we're going to cover up this term. So now we have to think, negative 1/2 of what number gives us negative 3? So I know that half of 6 is 3. So negative 1/2 times positive 6 is going to be negative 3. So I know that this is going to be 6, 0. And notice the scales here, they went by 2. So 2, 4, this would be 6, 0. Now I'm going to let x be 0. Cover this up. 3 times what is negative 3? That's negative 1. And remembering these going by 2's, negative 1 is going to be right here. And then we draw a line between them. Okay? So I want you to try to use the cover-up method for the remainder of these. If any of that went too fast, feel free to replay it. And I will talk with you individually or in small groups to give you support on this. Thanks.